Hi, everyone. I'm Josh Morrill. Welcome back to SoftInWay Spotlight. Today, we are joined by Aditya and Vishal, two members of the team from Thrustworks Dynetics, who are developing advanced turbopump technology for rocket engines. And their mission is to provide affordable access to propulsion systems for aerospace applications and to shorten development time. And we'll be talking more about their work, their development work, and how they're using AxSTREAM throughout their design process. But right now, I'll throw it to you guys if you can kind of give our audience, a little sneak peek into who you guys are in some of the work that you're doing right now.
Okay, so hi, I'm Vishal and he's Aditya. We are working on Turbopump. We're making this Turbopump product for our ANYA subsystem platform. Trying to develop it. We are a propulsion company. We basically make any propulsion system from small rockets to satellites, micro satellites to big rockets. Right now, the product that we are leading is Turbopump. This is a turbopump for a 20-kilometer rocket engine. And yeah, we are utilizing AxSTREAM for making the process more iterative, faster iterative. Yeah.
Yes. So, hello everyone. Myself Aditya. I am aerospace engineer and turbomachinery lead here at Thrustworks Dynetics. So currently I am leading the turbopump assembly development right from design to the actual conceptualization along with Vishal. And we here at Thrustworks Dynetics are designing an innovative propulsion system for a commercialization. Yeah.
Perfect. And, um, I guess a good place to start here is people that are just tuning in, just watching, just learning about you guys. What makes the turbopump design such critical, as part of the systems that you're working on, rocket engines, satellites, things like that. What is so important about that turbopump?
So basically, turbopump is the heart of liquid rocket engine. So turbopump is very critical from the perspective that for your rocket engine to operate, you need a good mass flows, a good pressure rise, a complete work of the subsystems, complete integration working very smooth throughout the operation. So that's why turbopump is very critical to the development of the liquid rocket engine.
Awesome. Yeah, and you talk about it being the heart there. I guess when you talk about going through the design process, what are some of the challenges that come with designing that heart of the rocket engine?
Okay, so Turbopump is a software, is a hard piece of hardware in which you will be dealing with almost all the problems that you learn in aerodynamics, right? You'll be dealing with cavitation, you'll be dealing with high vibrations, you'll be dealing with mechanical problems. So these sort of problem make this system and its design process a very multi-objective process. So that's a kind of trade-off.
Basically, for the turbopump to operate, you have multiple subsystems working very harmoniously with each other. So you have pump, cryo pump, basically like oxidizer propellant pump, basically, and to drive those pumps, you have turbine, right? And the complete integration is happening on the shafts and bearings and seals. So you need all those subsystems to work harmoniously at the critical time. So that's why turbopump is very critical for the development of the complete rocket engine.
Awesome. And for our audience, if you could kind of tell them what stage you're at in that development with the turbopump, what has the process been like, and where are you guys currently at with it?
So we started with designing process of Turbopump 3 months back. Right now we are at a stage where we'll be starting testing of our subsystems, subcomponents like pump and turbine. So that is where the development process is right now.
Yeah.
Awesome. And have you guys set any performance targets or design constraints that people should know about, that you guys have had to work around, and that have driven the turbopump architecture, the specific one that you guys are working on?
So generally what happens is requirements are driving the whole development of a turbopump. There are a set of requirements that we have to fulfill for the whole engine. But there are also constraints because you want a faster iterative cycle. You won't keep your objectives to be very idealistic, I will say. Like you won't say on the first day of the design cycle that I want 100% efficient turbo pump or anything like that. You'll try to dive down on the things, down on things, and try to get a viable design first. So and then test it. Whenever you're testing, you're basically validating your theories, right? So that with that those kind of constraints are what driving our turbopump development basically.
Yeah, basically, while complete development cycle, you have to, get through to the testing phase as soon as possible, because that's when you will actually learn that verify your theories, your assumptions, and validate your whole architecture. So that's why going to the testing phase as soon as possible throughout your development cycle is very crucial. And that's where we are right now. Like in upcoming months, we will be doing our component level testing. Yeah.
Very exciting, very exciting. And when you guys were embarking on this development process, where did AxSTREAM come in? When you guys were trying to figure out how you wanted to go about it, any softwares that you wanted to utilize during this process, where did AxSTREAM come in, and why did you guys want to choose it?
So we were in the conceptual phase of design process when we were sort of looking at products that will basically help us in optimizing our objective. Our objective that time was to bring out a faster and iterative design cycle. So with that kind of objective, then we onboarded AxSTREAM as a viable partner for us.
So right from the initial stages of the conceptual sizing only, we had partnered up with the AxSTREAM.
On the AxSTREAM aspect of this, what specific parts of AxSTREAM modules have you guys utilized, and how has that helped in terms of evaluating your turbopump design trade-offs and some of those constraints that we talked about earlier?
So during every phase of our design process, we have been helped by different modules from AxSTREAM. The part of process starts with freezing requirements. AxSTREAM system simulation help us in that. Then there is also the whole workflow of designing a turbine or designing a pump, in which AxSTREAM's own design software comes in a very handy way. There are primary design phases where there are modules that can cater to that requirement. There is also CFD module that's very helpful to us. A lot of our workload for developing a whole design model from zero to one is basically taken care of by AxSTREAM. So yeah, that's
like as we told earlier that AxSTREAM came very early on for the conceptual sizing. So a preliminary design of the whole subsystem to the computer-aided validation of that subsystem is whole handled by the AxSTREAM. And the trade-offs that we need to take care of with respect to RPM, with respect to power match, with respect to mass flow requirements, cavitation margins, NPSH. So those technical details are also taken care of in the design process with the help of AxSTREAM. So those technical parameters and performance maps are also helpful while designing the subsystem. So yes.
Yeah, and when we're still building out the platform, designing it every single day, working with companies like you, trying to figure out what works best, and a lot of that centers around holistic design. So obviously you're designing this turbo pump, but how it's going to interact with the full system. So in terms of that, how have you seen AxSTREAM been able to take into account those subsystems and the full system around the turbo pump, not just the specific pump, or whatever component that you're working on. What have you seen from that aspect of AxSTREAM, and has that come to fruition for you guys at all?
Okay. So what happens is for a newer teams like us, when we're starting a development of a totally new system, we don't have really design of experience for that system, right? So changes, if you have to do any change, your process has to be that much, analysis process has to be that much faster. Your design process has to be that much faster. So in this context, what happens is whenever we have access to a tool like this, whenever there has to be a decision taken, the whole change in design of the holistic system and then analysis on it becomes very much faster. So I can have a design, I can have an idea of some design change that could benefit us on matrices or like efficiency, NPSH, anything. We can just test it out in, let's say, 2-3 hours, and we can take a decision. Are we going for that or not?
Yeah, like what we used to do earlier was in the design phase, you have to rely on Excel tools and a lot of theory to actually solve those problems. But with AxSTREAM coming in picture, the iteration loop is very fast. So the components that need the design, basically specifying those specifications and designing the component and validating those components, so that iteration loop becomes very fast. So that's how AxSTREAM is expediting the design process.
Mhm. And you guys are talking about how, speed is such an important part of what you guys are doing,
Yes.
and, doing it quickly. But what's also important is not having those trade-offs where, a lot of the data that you're using might be off in certain situations. But what has been your experience with that, where, obviously you're trying to do it quickly, but you're also trying to do it effectively as well? What has that process been like in the context of AxSTREAM as well?
Okay. So what happens is, let's say you're changing some parameter and you are able to view this parameter on CFDs at design point, right? But that might affect the operating range in off design regards, right? So there we utilize AxSTREAM to basically look at off design performance also of the design, rather than just looking at a straightforward operating point. And because the effort, the computational power required is very low, because you are using now DOEs rather than simulation softwares. Yeah, it becomes then very faster to look at the holistic view of this, holistic effect of the action that you're taking.
Yeah, because design of experiments is very useful tool, since you need for a proper component sizing, you need to have the on design conditions, nominal conditions, and off nominal conditions to be run and taken into picture. And with the utility of AxSTREAM's design of experiments, we are able to generate those DOEs very quickly and get the performance maps also with help of that. So yes, that speeding up the loop comes in that handy.
Mm-hmm. And I don't know if you guys have thought about this at all, but if you think back on this, last 3-4 months or so, however long you've been working with it, if you didn't have a tool with some of these the performance maps and different aspects of what you're talking about, which helps you kind of streamline this process. If you didn't have those things, what would this process look like for you guys, do you think?
Yeah, as I stated earlier, that in that case, we need to rely whole and soul on the
Traditional tools.
traditional tools. Yeah,
Yeah.
traditional tools. Go to the Excel, do the iteration loop, run to the CFD very quickly in the iteration loop. And as you know, CFD takes exhaustive computational power. So that loop will, drastically increase, to be honest. Yeah.
And as our philosophy relies on build, test, break, and repeat. So with this philosophy, we need to get to the testing phase as early as possible. So I think that could be a point where we would have been lacking if we didn't have a tool like this.
Because action is for the startup like us, where we are innovating propulsion system, we need to get to the action part as soon as possible, not just rely on theory and doing the research extensively. We intend to do the same thing, but to the get to the action point, get to the testing as soon as possible.
Yes.
Awesome. Awesome. And for that audience that we're talking about, what if they want to know what are some of your next milestones with this turbopump development or just general, rocket engine development or satellites, anything that you're doing right now, but maybe specifically with this project, what are some of the next milestones that you guys have?
So from an organizational perspective, we are making this ANYA engine platform, which will serve as a platform engine design for our upcoming products. This is a 20 kilonewton engine, liquid rocket engine in a Kerolox configuration. So a very important part of this is turbopump. And for this, we are in testing phase, as I already tell you. We are really excited about it. The testing phase is starting. So those are the milestone which we'll be looking at in next 2-3 months.
Yes.
Awesome. And I know this isn't a very technical question, but I guess what excites you about that process? Is this kind of a novel thing for you guys, but also maybe the competitive landscape? Like what are some of the impacts of this, the ramifications of this, in your area, but also just in the full sector as well? Like how do you guys view this, and how excited are you guys for it?
Yeah, like while earlier discussion only we specifically elaborated that turbopump is a heart of engine. So imagine working on something that is pumping whole propellants to the that extend that interesting machinery. So imagine working on something challenging like that, innovative like that. So yeah, that gets you up in the morning, running, thinking, how do we get to the action point as soon as possible. And that's what excites us most about the designing such critical component.
Okay. And also in market like India, like we do not really have companies that really have a turbine-based turbo pump here, right? So that excites us that we are building a product that's very new to our market, very new to our country. So basically doing something that nobody else has done in our country. That is a key aspect of why it is exciting to us.
Apart with turbopump, there are also another subsystem that are also designed by us, innovated completely by us, tested also by us, and along with those subsystems, such innovative propulsion equipments, components will be commercialized with the help of Thrustworks Dynetics in India. That's for sure.
And I know we talked about kind of the traditional tools beforehand, but for startups like in smaller teams, like yourselves working on propulsion systems, where do you think these integrated turbomachinery tools like an AxSTREAM make the biggest difference? Do you think it is the speed, or are there other aspects that when you're using this novel piece or or this specific module, was there anything that you saw aside from the speed that you were surprised about or pleasantly, that helped you guys through the process?
So speed is obviously a important part of the process, right? But another important aspect of this is, let's say for smarter engineers is always that you will be distracted working on some problem that shouldn't be a problem at the first place. A lot of that happens, and let's say your core USP is building a turbo pump, but you're stuck in making the software and infrastructure behind that. That really distracts you from your objective. I think startups are, with the help of tools like this, startups are benefited in this way the most because they are not stuck solving problems that are not their core problems. This enables them to iterate faster.
Correct. Because as you said, speed is essential, but we should not get invested early on in figuring out something rather than actually doing it. So these kind of tools with your experience and understanding the technology helps us actually build the deliverable that we are needed to deliver.
Awesome. And aside from AxSTREAM, I guess, what has your experience been with the SoftInWay team? Going through this process, trying to be a partner, and we've tried to take pride in helping you guys throughout this. This is your baby. This is something that you guys are trying to develop. But what has your experience been like with us, and anything that you can share about that?
Yeah. So the tools that are at AxSTREAM disposable for us. So what they actually enable us to do is the quick iteration, that's for sure. But even if the technology for some specific problems is not available with AxSTREAM also, they are open to run the experiments alongside us. So that actually is very crucial thing for the novel problems that we are dealing with right now. So I believe, yes, such openness to the, actually adapting to the new environment, new problems is actually very crucial for the development of such critical subsystems.
Yeah, and shout out to AxStream, SoftInWay guys who are helping us when we are posting our problems to them. The reply is really quick. We are used to deal with such products, and the one thing that really problematic for us is delayed replies on problems that we are facing. In that aspect, I have seen AxStream SoftInWay as a superior product to others.